So I am Rupak Vishwas, Google Cloud Camp Facilitator from third year BTech. And in this session, we'll be looking into IaaS, that is Compute Engine, PaaS, that is App Engine, Function as a Service, and we'll be looking into some database and security also. So in the last session, we have already a basic overview of what these terminologies means, like the IaaS or Function as a Service, these things. So hope you will get some more brief overview of these terms in this session. So Google Cloud offers a variety of compute services in as many different options. These are basically compute engine, app engine, then cloud function or cloud run, Google Kubernetes. So we will be looking into this individually one by one, and when we should use them, and what are the difference between them as compared to the others. So starting with compute engine, uh, the compute engine lets you create or run virtual machine on Google infrastructure. So if you have used any virtual machine like uh, VMware or VirtualBox, you might know what virtualization is, and this is similar to this thing. But in this case, you are creating your virtual machine in Google's infrastructure, and this is similar to buying a computer. So there are custom predefined machine types, like they will be giving options some which kind of machine you want to uh, use for your solution, like EC2 or EC2 large, EC2 medium, or any kind of machine. There are variety of ranges. Then there are optimized VM virtual machines, like you can load your virtual machine OS image also, but they already have some default images, so that uh, so there are some option for using different virtual images, like Gentoo OS or Linux or Windows Server, and you can use your custom pre-built images also. For sizing, you will be asked to how much RAM you want to use, or how much disk space you want to use. So this is basically like choosing your computer, which computer you want to use, and you will be running your application or infrastructure on those virtual machines. So this in this case, you have to take care of the system configuration also, and configuration related securities. Next, we have serverless options, where you don't need to buy a server or configure them. They already build a server for you, and you just deploy your application or functions in that platform. So this let me deep dive into this pyramid. Here, you in the base layer, you can see like there is internet connectivity, physical servers, network hardware, then physical security. So if you don't use virtual machines, or then you might have to use any physical device for your server. Then you have to take care of internet connectivity, so that the internet connectivity is available for 24 hours. Then for physical server, there should be physical safety also. You have to take care of physical damage, so that uh, and there are network hardware, network adapters, and physical security mainly. So in case of this compute engine or virtual machine, you don't need to worry about these things. The base layer, the Google provider already secures about this base layer. Then you have to work on these things: scaling, VM provisioning, and ops and security management. But in case of serverless, you don't need to worry about this thing also. The scaling is done automatically. Let's say you have deployed some application in any serverless system. Then, as long as your network traffic arises, the server, that is your application, will automatically expand the performance. You don't have to scale manually; it will be done automatically. In serverless system, your only focus will be like developing the application and monitoring the performance. So in case of the serverless, there are two options mainly. That is app engine and uh, cloud function or cloud run. That is, yes. So serverless computes gives us auto scaling. So it's automatically scales based on your network traffic. Then there is no infra management. You don't need to manually configure all the systems configuration or network configuration, your port configuration, which port you have to open or which port you don't have to. Then all the other system requirements. Then it gives us a lot of speed in deployment. You just need to build the application, and your hosting will be done in half an hour or something. It is very fast. So these are the options we have as our serverless application. So another thing I want to, is my screen visible? I think not. Let me reshare. I think my screen freeze.
Yes, Bhaiya, it's visible.
But uh, my screen is showing the Google Cloud Serverless Compute product portfolio. Is it showing the same? Yes. Okay. Now updated.
Yes, Bhaiya,
So
Google Cloud Serverless Compute.
okay. So as a serverless service, one thing I need to mention that the serverless terms means that we don't need to worry about the server. The server exists, but we don't need to manually configure them. The application automatically runs on multiple servers, but the server exists. So the Google Cloud provides these things as serverless services like App Engine, then Cloud Run, and Cloud Function. So we use this on different use case scenarios. Like if we have source-based web application, mainly web application, we can run another kind of application also. But for this is used mainly on web applications. For running source-based web application, we use App Engine. Then if we have a container, there is a Docker image or something, then we can run the container on a cloud run. If we have a single container, for multiple container or cluster, will be there are Kubernetes. And if we have a single function or event-driven function, there is cloud functions as event-driven function as services. So App Engine is a type of platform as a services. In this, as this is a serverless process, we don't need to buy or operate the hardware or infrastructure or anything. We don't even need to worry about the OS itself. For managing the server or configuring, yes, we don't need to manage servers or configuring the network requirements, security, etc. There are a wide range of language and tools already installed those in those machines, and they automatically scales. We don't need to create multiple instances uh, of the same application. The on the base of the traffic or request per minute or request per second, the service will automatically scale. And you need to just provide your source code and how you are going to deploy. Could be like, for an example, if you have a Node.js server, there are certain steps for which you like uh, with which you are deploying your server. Or let's say you have a Django application, so there are certain steps how you deploy your server. So you just have to provide the source code and provide the steps how you want to host this server. The app engine will automatically host your system for you. And these are some application language that the app engine supports, the Node.js, the Java, Ruby, C Sharp. Also, you can bring your own language runtime also. In that case, you have to tell them how to install your own language. So, in case of Cloud Run, this service connect and extend cloud services. You can use multiple cloud serverless functions in a connected manner. Then, in case of serverless functions or functions as a services, there are events and triggers. And next, this is how cloud function works. There is a term called events and writebacks. So every cloud function responds on an event, and it gives some response on the as the output of the function. So as we can see, this cloud service emits an event, then this function computes something on the basis of the event, then it writes back some data on the cloud service. In between, it can invoke some other service or other APIs also, like it can invoke some other cloud functions or other cloud services or anything. Then instead of this cloud service, this can be a user also. User can emit event, then the cloud function can respond to this event, and the user can get back the data. So this is how cloud function works. This is similar to a regular function we generally create in our code, in our codes. So the key difference between our function in our code and the cloud function is it is deployed individually and anyone can access. So by means of anyone, I should say that you have to limit the person like who are you given want to give the access to this function. Next, the customer asks like how we can use existing binary and we can't be locked in, or can you support this language? I write my application in this language, then that is pretty unusual. For example, like for web technologies, there are very famous frameworks like Django or Node.js or something, but anyone can build their application in C, which is pretty unusual, and they want to host their application. So in this case, I think cloud function can't help. So how we can support those? So there, this term comes. It is container. So containers are like container like VM virtual machines, but this is very lightweight. It supports any language, any library, or any binary medium, and any ecosystem-based image. So you can deploy a single container or multiple container at scale. So for running single container, if you already have a configured container, you can run that container on Cloud Run. Yes, you can run that container on Cloud Run. But you let's say you want to load balance the whole load coming to the server because you have a large amount of customers and there are lots of pressure on the server. So you want to load balance across multiple images or containers. So a fundamental different way of managing application requires different tooling or abstraction. There are deployment problems and monitoring. You have to monitor all those containers. You have to isolate some of the containers so that for security purposes, you have to update some of the container on regular basis, and there are scaling and replication problems also. So there are Kubernetes to handle those kind of problems. So what Kubernetes does, it schedules which container should run when, and it decides what pods to run on which nodes, and it keep the container running despite of any failure. It can scale multiple container on or set of containers based on the traffic. Then you can name all those containers. There are load balancing. You can balance a single load on different multiple instances. Then you want to add some storage, you can add them. There are proper logging and monitoring with what happening with each of the containers. Then there are debugging and introspection facility also attached to each container. One good thing about these things, this container cluster is if a single container is get hacked or get destroyed or failed, so it won't have affect the total application because as a whole, it if one node is affected, the others will run independently. So Kubernetes Engine is a managed environment for deploying containerized apps, and you can host multiple Docker images in these facilities. So where Kubernetes Engine fits in Google Cloud, we have already seen like there are compute engine, app engine, cloud function, and so first one was infrastructure as service. It was you have to configure the server. This next to app engine and cloud function were serverless. So is the Google Kubernetes engine is serverless or with you have to configure server? So this is none of them or both of them. This is actually hybrid system where you have some partial access to the server. So another thing we have is cloud run. So let's say you have a single Docker image and you want to just run the image. That's it. You don't have a multiple image and you just want a single event to run. So Cloud Run can do this in seconds. It automatically builds some HTTPS. It will provide you some HTTPS URL so that you can access the service. It supports any language with any libraries. You don't need to worry about cluster management. So these are lots of services. You will be confused about which service you should be using and when you should use those services. So there is a flow diagram on which service you have to use. Like if you are so let's say what kind of app are you building. So if the app is cloud or firebase driven by cloud or firebase events, then you can just use cloud functions. Or if this app consists of stateless HTTP. Stateless HTTP means like all the HTTP requests are independent. No HTTP request is depends on its previous request. So all are independent. So if your application consists of stateless HTTP events and you don't need Kubernetes services, then if you have custom languages and system libraries, then you can use Cloud Run. Or if you have some supported language, or then if your application is if your the unit of deployment is application, then you can use app engine as a standard environment. Then or if you have only a single function, then you should use cloud function. And for more detailed description of this flowchart, you can visit to this URL. The slide will be shared. You can check this out. So this flowchart is actually pretty large. Actually, it's a brief structure. So next we will be looking on Google Cloud Storage Services. So as we mentioned earlier in our previous session, that in every company uh, there are data. So everybody is working on data. Here, with an application is accepting some user data, uh, storing in some databases and running some query or analytics, and it's applying some data as well. So for that, we need a database or something to store that amount of data. So Google Cloud provides us a number of options to store our user data. These are memory store, cloud is these are in memory storage, relational storage, then NoSQL storage, analytical and object block file, this kind of storage. So starting with the in memory storage, so you might have known that database is something like uh, in our computer we have various kind of storage system. Like the first one is cache memory, then there is RAM or random access memory. There are our primary storage or the hard disk or SSD. So this memory store is uh, running on our RAM, completely running our RAM. Some of the example are Redis server or Memcached something server. So if you are if you want to deploy some temporary database or where you won't be putting too much data, you just want to save some OTP or something like this, then you should use memory store. It will be extremely fast and best for storing session storage, etc. Then databases. The most common type of databases for structured data. Structured data means the data is uh, divided into row or columns or tabular form. So these are some options: Cloud SQL or Cloud Spanner. So Cloud SQL also supports MySQL and Postgres and other SQL servers. And Cloud Spanner is a scalable relational database. Then you have semi-structural data uh, as the index-based database. Then there are NoSQL database. One is Firestore and another is Cloud Bigtable. So Firestore is serverless document store. This is connected to our Firebase IO. Then we have Cloud Bigtable for low latency, scalable, key value and wide column store databases. And there is mainly for analytical, but we can use for general purpose also. There is BigQuery. So this is mainly for analytics. It can give lots of analytical data on stored data, but we can use this for our primary database also. Next, we have object storage, the cloud storage. It can store unstructured data or object or blobs. Blobs means like when video streams also. So then there is some persistence disk. This is for storing some local VM file storage. Like if you have some virtual machines and you're gonna stop that virtual instance for a time, but you uh, because there are billing problems. If you are running some services, then you have to pay for it. But you think like this service I don't want to pay, but I will use this service in near future. So one thing you can do is like shut down the service, take a snapshot of the disk, and later you can start another virtual machine from the disk. So storing those kind of disk, you can use this block memory or persistent disk. Then there is file store for uh, storing large amount of files. So there are three common use cases of cloud storage. One is content storage and delivery. storage for data analytics and general compute, and backup and archival storage. So first kind of storage, this content storage and delivery is the most active one. So you gather some data from your users and store them in a database. Use run some query or run some uh, functions on that data and return the users some of the data. Then for your internal users, like for running some survey or something, you use some analytical database for gathering some analytics. Then there are backup and archival storage for obviously for backup purpose. So these are some example of structured data and unstructured data I was talking about. So as you can see in structured data, this is in tabular form. There are rows and columns. In case of unstructured data, there can be any kind of data. Like there can be some of structured data like transaction, or there can be notes and text, that is normal text data. There can be some voice transcription, that is binary media, or email, that is some kind of blog data. So again, we have another flow chart for choosing which kind of storage system will meet my needs. So let's start from here. Is your data structured? If no, then simply go for cloud storage. Then if yes, then is your workload is analytics. So if you don't need analytics and your data is not relational, use data store. And if your data is relational, then again, if do you need horizontal scalability? If yes, then use Cloud Spanner, or else use Cloud SQL. Then if you want analytics on your data, then for low latency, use big Cloud Bigtable, or else you can use BigQuery. Next, we will be looking into Google Cloud Security and IAM. So these are the Google's infrastructure security layers. Uh, First, we have hardware infrastructure and service deployment, user identity, storage devices, internet communication, and operational security. So these are different layers we have in a system, and security measures are taken in every layers. So some of the layers, uh, Google already applies some security measures in all. We don't need to worry about them. We just configure some of the only some of the layers, like the user identity or storage service, or this. For hardware infrastructure, we don't need to worry. In case of cloud services, Google cloud provider would already look into this. There are service accounts control for server-to-server interaction. These service accounts provides an identity for carrying out server-to-server interaction in a project. Then, like for every service you use, you need to have a service account, so to access that service. And main motive for this thing is like uh, you want to access some content on a server. So for accessing those content, you need some credential, and you don't want to keep your own credential for accessing those data. So there are service accounts and service access token you can configure in your application so that it can access some of your data from your another service. So service accounts are identified with this email address, project number, then hyphen compute at the rate developer.googleserviceaccount.com. Or there are another email account like project ID at the rate. there should be your project ID and project number as well, and you can the admin can give privileges to this accounts as well. So this is another bar chart we can use to compare between all those services like on-premises, infrastructure as services, platform as services, and managed services. So in case of on-premises services, you have to worry about all these things: content, access policies, users, deployment, web security, to up to hardware level securities. But in case of infrastructure as services, from compute engine to Kubernetes, the Google already take care about hardware to operation level security. You have to configure those identity, web security, deployment, and your content on infrastructure as services. Then in case of platform as services, you don't even need to worry about identity. You only have apply security on your application. Then for fully managed system, then you just need to deploy. But that's it. So data access is almost always the customer's responsibility. So you don't need to. So cloud identity and access management, that is IAM. So let's admin authorize who can take action on specific resources. So that is who can do what on which resources. We can there is a section to manage those things. Like you have multiple services and you don't need to give all the services to all your clients. You can specify which application will you use which services, and you can do this by using IAM management tools. There is identity and access management tools. Usually, you can create some uh, rules or section to specify who will be accessing which resources and which type of permission they can get, like edit permission or view permission or delete permission or whatever. So IAM policy can be applied to any four of type of this user resources. Is any Google account, this test@gmail.com or Google account. Then you can give IAM policy to any service account that I talked about to access some resources from an application. Then you can give for giving multiple users at a time. You can create Google groups and give the group the service access. Then also for your large for giving large number of people their Google workspaces, and you can give permission to Google workspaces individually. So these are some types of IAM roles already exists. The basic one is the service account, where you can mention who can access which resources, what can he do. Then there are some predefined roles that are mostly used. You can just choose the role and select them. Then there are custom roles as well for on the basis of your applications. So I am predefined roles, particular Google Cloud services in a project. So these things we already talked about, and IAM predefined roles offer more fine grained permissions on particular services. So there are some predefined roles we talked about. So these are some predefined roles: compute.instant.delete for to some instance or get permission to some instance. You don't need to configure all these things manually. You can just if you want to just give delete access, you can just use some predefined permission and choose them. For any other complex type of permission you want to set, you can go for manual uh, instant operator rules. So that's it. Thank you everyone for joining this session. So if you have any question, you can ask.